In this tutorial, we'll learn about the embedded system, including its basic architecture, components, and real-world applications. We'll also explore how hardware and software work together in embedded systems. An embedded system is a specialized computing system designed to perform a specific task within a larger device or system. It combines hardware and software to control, monitor, or manage the functions of the device efficiently and reliably. An embedded system consists of several important components that work together to perform a specific task. First, the input device is used to collect data from the user or the environment. Examples include switches, keyboards, and buttons. Next, the processor acts as the brain of the system. It processes the input data, performs calculations, and controls the overall operation of the embedded system. The memory stores program instructions and data needed for processing. It helps the system remember information temporarily or permanently. The power supply provides electrical energy to all components of the embedded system, allowing the device to function properly and continuously. Finally, the output device displays the result or performs an action based on the processed data. Examples include displays, motors, speakers, LEDs, and alarms. All these components work together to make embedded systems efficient, reliable, and useful in everyday electronic devices. Microcontrollers and microprocessors are both important electronic devices used in computing systems, but they have different purposes and features. A microcontroller is a compact integrated circuit designed for specific control tasks in embedded systems. It contains a processor, memory, and input-output devices built into a single chip. Microcontrollers are commonly used in devices like washing machines, traffic lights, and home appliances. They consume less power, cost less, and are suitable for dedicated applications. On the other hand, a microprocessor is mainly used for general-purpose computing. It contains only the CPU, while memory and input-output components are connected externally. Microprocessors are used in computers, laptops, and advanced systems that require high processing power. They are faster and more powerful than microcontrollers but consume more power and are more expensive. A microcontroller is a small electronic device that acts as the brain of an embedded system. It is designed to perform specific control tasks efficiently within electronic devices and machines. A microcontroller contains several important components integrated into a single chip. The first component is the CPU, or Central Processing Unit, which processes data and controls all system operations. The RAM, or Random Access Memory, temporarily stores data and instructions while the program is running. The I/O ports, also known as input and output ports, allow the microcontroller to communicate with external devices such as sensors, switches, LEDs, motors, and displays. In addition, a microcontroller contains timers, which are used to control timing operations, generate delays, count events, and manage tasks accurately. Some microcontrollers also include communication modules, analog to digital converters, and memory for storing programs permanently. The working process of a microcontroller begins when it receives input data from sensors or user devices through the input ports. The CPU then processes the data according to the instructions stored in memory. After processing, the microcontroller sends output signals to connected devices, such as turning on a motor, displaying information on a screen, or activating an alarm. Microcontrollers are widely used in embedded systems because they are compact, reliable, low cost, and consume less power. A microprocessor is the central processing unit of a computer system that controls all operations and performs calculations. It is mainly designed for general-purpose computing and requires external components like memory and input-output devices to function. The microprocessor consists of three main internal units. First is the arithmetic logic unit ALU, which performs all mathematical operations such as addition, subtraction, multiplication, division, and logical operations like AND, OR, and NOT. Second is the control unit CU, which manages and coordinates all activities inside the processor. It controls data flow between memory, input-output devices, and the processor itself. Third is the register array, which is a small, high-speed memory inside the processor used to temporarily store data and instructions during processing. A microprocessor also uses cache memory, which is a small but very fast memory that stores frequently used data to speed up processing and improve performance. This reduces the time needed to access data from the main memory. To work in a complete system, a microprocessor interacts with input devices like keyboards and sensors, which send data into the system. It processes this data using its internal units and then sends the results to output devices such as monitors, printers, or speakers. Embedded systems often include communication features that allow them to exchange data with other devices. Communication is essential because it enables the system to send and receive information for proper control and operation. There are two main types of communication in embedded systems: wired and wireless. Wired communication uses physical connections to transfer data between components. It is reliable and commonly used for short-distance communication inside devices. Wireless communication uses signals instead of wires, such as Bluetooth, Wi-Fi, and infrared. It allows embedded systems to communicate over longer distances and connect with external devices like smartphones, computers, and other smart systems. Through communication, embedded systems can coordinate tasks, share data, and respond quickly to external commands, making them more efficient. Consumer electronics are everyday electronic devices designed for personal or home use that often use embedded systems to function. These devices include products like televisions, smartphones, washing machines, microwave ovens, digital cameras, air conditioners, and music players. Inside each of these devices, an embedded system controls specific functions, such as processing user inputs, managing operations, and controlling outputs. For example, in a washing machine, the embedded system controls water level, washing time, and spinning speed. In a smartphone, it manages communication, apps, display. Automotive transportation refers to vehicles and systems used for moving people and goods, such as cars, buses, trucks, and motorcycles. Modern automotive systems heavily use embedded systems to improve safety, performance, and efficiency. In vehicles, embedded systems control many important functions. For example, the engine control unit (ECU) manages fuel injection, air control, and ignition timing to improve engine performance and reduce emissions. Safety systems like ABS, anti-lock braking system, airbags, and traction control also depend on embedded systems to react quickly. Embedded systems are also used in navigation systems, digital dashboards, parking sensors, and entertainment systems. They help drivers get real-time information like speed, fuel level, and directions. In modern transportation, advanced features such as electric vehicles, autonomous driving, and smart traffic systems all rely on embedded systems to process data and make decisions. This makes automotive transportation safer, smarter. Automation systems are systems that perform tasks automatically with minimal human intervention, using embedded systems to control and manage operations. This input is sent to the embedded controller, which processes the information and makes decisions based on programmed instructions. Automation systems are widely used in industries, factories, smart homes, and robotics. They improve efficiency, reduce human effort, increase accuracy, and enhance safety in different applications. An automatic streetlight system is a simple example of an embedded system that uses a microcontroller or microprocessor to control lights based on darkness. It works using a light sensor, LDR, light-dependent resistor, as the input device. The embedded system processes this input and decides to keep the street light off. At night, when darkness increases, the light intensity drops. The microcontroller processes the signal and identifies that it is dark enough to turn the light on. After processing, the system sends an output signal to a switching device like a relay. The relay then activates the street light, and the lamp turns on automatically. When daylight returns, the process reverses and the light turns off again. Embedded systems offer many benefits. They are small in size, so they can easily fit inside different devices. They use low power, making them ideal for battery-operated systems. They are cost-effective because they are designed for specific tasks with minimal hardware. They provide high reliability, working consistently for long periods without failure. They also deliver good performance and often support real-time operation, responding quickly to inputs and producing immediate outputs. You have completed the Embedded Systems tutorial. You learned what an embedded system is and how it works with input, processing, memory, power supply, and output devices. You also understood the difference between microcontroller and microprocessor, and studied their main components and functions. In addition, you explored communication, consumer electronics, automotive systems, and automation systems with real-life examples. Finally, you learned the key benefits of embedded systems such as small size, low power, cost effectiveness, high reliability, good performance, and real-time operation.